Hi folks, this is the Advanced Math Chapter 12 on Vectors, Part C, Homework Quiz Recap. This is where I go over a question or an example that's similar to the Homework Quiz Part C, but a little bit different. So if you haven't taken Quiz C yet, or if you've taken it and you want to take another shot at it, this is going to sort of cover the same topic. Might be worth looking at. So the question I'm starting with is this one. Given that you have vector A with components 2, 3, and vector B with components 1, 5, one question you could ask is, are vectors A and B perpendicular? So this is really a two-step question. The first thing that we need to ask ourselves, or one way of approaching this question, is to say, what's the dot product of A and B? And depending upon the result of that calculation, you can make a determination about whether the two original vectors are in fact perpendicular. So, step one, compute A dot product with B. And the way you do this is you take the corresponding components of the two vectors. So the x components of the two vectors are 2 and 1. So we'll multiply those together, 2 times 1, and we'll take the y components, 3 and 5, and multiply them together. And add those two products. So we'll get 2 plus 15 is 17. So that's the result of multiplying vector A and B using the dot product. Now, so when you do the dot product of two vectors, you should get a scalar. There is another type of multiplication called cross product that gives you a vector as a result, and we may or may not have the chance to look at that later on. But the next question is, what does that mean? Well, from this, we can conclude that vector A and vector B are, drumroll, not perpendicular because the dot product was non-zero. So anytime you calculate the dot product for two vectors and you get a result that is not zero, then you know that those vectors are not perpendicular. If you do the dot product of two vectors that have non-zero lengths and you get a dot product of 0, then that means, since you're multiplying these the magnitudes of the two vectors times the cosine of the angle between them, which is another way of expressing what we just did here, if that's 0, it means the cosine of the angle is 0. The cosine of an angle is 0 when the angle is 90 degrees, or perpendicular. So perpendicular vectors have a dot product that's 0. And if you find the dot product is 0, the reverse is true. Those vectors have to be perpendicular for that to be true, as long as their lengths are non-zero. That's it.